I'm very delighted to have you tonight. It's again your teacher Slide Sabaiga, introducing to you A-level applied mathematics. And that is the concept of mechanics. Today, I know I'm dealing with the starters, my local students who are starting mathematics at this level, my international students who are also starting the concept of math at this level. You are welcome. This is part of mechanics. Unlike the pure, if you have ever seen me in pure math, forget about that. Today we have come to talk about science. Pure was art. So today we are talking about science, and that is mechanics, part of applied mathematics. So we want to see how math is applied, basically in the sciences. Now, my new starters, students who have joined me today, you shouldn't worry about mechanics. You'll see some kind of physics, which is part of science, but this should not scare you. I'm going to treat you at a very, very steady pace. So we need now to go and see what mechanics is. So dear class, those who are seeing me live, who are viewing me live, and those who are in my class, when someone talks about mechanics, what runs into your mind? Exactly, a branch of science. So we are going to discover today that mechanics is a branch of science which deals with the effect or the effects that forces have on bodies. A branch of science which deals with the effects that forces have on bodies. Very interesting. We should put this down by definition, that mechanics is a branch of science that deals with the effects that forces have on bodies. Forces have on bodies. Where force is a pull or a push of a particular body, of anything. So, we want to go and see this branch of science that deals with those effects of forces. When a force acts on a body, that is a pull or a push, you expect change in motion. You expect change in position. You see, a load, sometimes you expect even change in shape. For example, a shear force can change shape of a body. That is the concept we have come to talk about today. So, the laws of mechanics are scientific laws. They come from observations and experiments, and so can never be considered as universally true. I want people to note me very, very clearly there. Laws of mechanics, they come from observations and experiments. So we cannot consider them as universally true. These laws agree with observed results to a particular extent, that they are accurate enough for most purposes. Unlike pure math, we saw pure math, which is an art, and its theorems are universally true. All the theories, the theorems of pure math are universally true. So, what are we going to observe here? When pure math or pure mathematics is used to solve a mechanical problem, I want people to note me very well. When we use pure math to solve a mechanical problem, because we need it, we are going to use it, it is very important, once you use pure math in solving a mechanical problem, to distinguish clearly. It is very important to distinguish clearly between the use of scientific laws and mathematical theorems. Hope people have understood me very well. So, our mechanics basically is going to involve a lot of conversions. You see, certain factors have a negligible effect on a problem. And if they have a negligible effect, so they are ignored. They are often ignored. For example, if we consider the effect of a slap of a baby from a baby of 2 weeks and a slap of an 18-year child or 18-year, being, you can as well ignore the effect of the slap from a baby. That's what I'm talking about. This has an advantage of simplifying a problem without sacrificing much accuracy. So in mechanics, we shall not too much look at the accuracy of a particular, problem. We are going to see a lot of conversions, a summary of conversions. For example, when someone talks about light, a word light, if it happens to be used in mechanics, this is considered weightless. That is light. A lot of these approximations are going to be used. When someone talks about a particle, object moving or object having no dimensions, it's considered as a point. That is a particle. You see, those are the words you are going to encounter. Before we look at the course outline, what is under mechanics as a branch of science learned in mathematics, we need to know some of the words which we are going to encounter. So you hear words like light. When someone talks about light in conversion, that is weightless. We ignore that. It is negligible. Something light, its weight is ignored. It is weightless. When someone talks about a particle, what runs into your mind should be object having no dimensions, considered as a point. So object having no dimensions. Okay, can consider a point, considered as just a mere point. So you will hear a particle travels. A particle, you see, that is a dimensionless object. Things like lamina, you hear about lamina, that is a flat object having dimensions of area only. Yeah? Lamina. Those are some of the words you are going to encounter. This is flat object having dimensions. When I talk of dimensions, hope you understand. Having dimensions of area only. Okay, so in our conversions, we need to know all that. When someone talks about hollow, the word hollow, that is three-dimensional shell of no thickness. You see? Hollow. Three-dimensional shell of no thickness. Very interesting. We shall count words like smooth. When someone talks about a smooth surface, for example, what runs into our minds as far as mechanics is concerned is a negligible effect of friction. That is smoothness. Frictionless. When someone talks about smooth, that is frictionless. Smooth is frictionless. I don't want you to consider this as physics. This is totally different. And I will not talk about any physics here. Whatever is required in this math of mechanics, I'm going to introduce it to you without referring to the physics. Because people always have that worry that mechanics is all about physics. That is not true. In this concept of mechanics, actually there are 6 major conversions which are supposed to be well versed with us. We have so far listed 5. We can talk about the last one as air resistance. Okay, in most cases here, air resistance that is a negligible effect, something which is ignored, unless somebody mentions to be used. For example, if somebody tells you that air resistance is not neglected, then we shall account for it. But this is ignored. Air resistance is also going to be ignored. When someone talks about air resistance, the assumption is it is ignored. We don't use it majorly, unless if it is mentioned. So unless mentioned to be used, unless mentioned to be used. So dear viewers, hope this is a very, very warm beginning. Immediately after a break, I'm coming with the topic outline. What are we going to talk about as far as mechanics is concerned? Don't go away, stay tuned. Yes, dear viewers, been on. Okay, so this is the course outline as far as mechanics is concerned. Okay, so the course outlines, mechanics is going to be divided into two. We are going to divide it into dynamics, effects of forces that involve motion, and then statics, the effects of forces without involving motion. So, dynamics, we are going to talk about vector mechanics, okay, motion in a straight line, force and Newton's laws of motion. We shall talk about linear momentum. I know everything here is familiar. You have ever seen it somewhere. We shall talk about power, work and energy. We shall talk about elasticity. We shall talk about circular motion. We shall talk about simple harmonic motion. And then we shall end dynamics with projectile motion. Everything here is familiar, very, very simple. We want to see the mathematical treatment of all these aspects. Then under statics, we shall start with the composition and resolution of forces. Then we shall move to friction, then talk about what we call the coplanar forces, then talk about jointed bodies or jointed rods. And then finally we shall end with the center of gravity. So for those who are going to read ahead of us, or for those who are not going to be in a position to get all the DVDs for mechanics, those who watch us as college teacher or recorded teachers, I know you'll have DVDs. Which DVD? A single DVD will not contain everything as I put it on a board. So what are you going to do? The course outline is already given to you. Very, very easy. You can read ahead of us. Yes, there are some books which I can recommend. But at your level, I can recommend only one book, that is Understanding Mechanics. Understanding Mechanics. Understanding Mechanics. So Understanding Mechanics, the author is Sadler. Yes, J. Sadler. You can go and look for this. There's other names which are not indicated, but Sadler, go with the Sadler, which will be easier for you. So, now, let us go and see part of mechanics called dynamics today, and that is vector mechanics. Immediately after a break, we are coming with our first topic in mechanics, that is vector mechanics. Don't go away, stay tuned. Dear viewers, we'll be back from the break. So this is how far we have gone. We have started with our very first topic, And that is what we call vector mechanics, which is part of dynamics. Oh, very interesting. So, topic outline of this. We are going to talk about, under vector mechanics, we are going to see resultant of vectors. Okay, we shall talk about the vector representation. We talk about unity vectors, talk about the magnitude of the vector, talk about vector resolution, and then finally talk about what we call the scalar product. The scalar product. This treatment of vectors in mechanics is totally different from the theoretical facts of pure mathematics about vectors. So don't confuse the little math we are going to talk about as far as vectors are concerned in mechanics, and then the broad view, outlook of vectors in pure mathematics. So this is for only mechanics. When it comes to pure math, it is also an examinable area. Vectors, an examinable area, very big one. At a local curriculum, 2 questions, 17 marks. International curriculum, it depends on what you are doing. Okay, so now let us go and start by the definition of a vector. Dear class, what is a vector? From your junior math, from your pure math, what can you talk about a vector from your other subjects? What is a vector? When someone talks about a vector, what runs into your mind? That is definition. Definition. What is a vector? Oh, I'm seeing those who are streaming live are sending their views. Somebody has said that a vector is a quantity with both magnitude and direction. Exactly. Exactly. Somebody is again bringing in the aspect of quantity. Now, what is a quantity? A quantity is an observable property. Very interesting. So, a vector is a quantity with both magnitude. When we talk of magnitude, we mean size, both magnitude and direction. Both magnitude and direction. That's what we mean by a vector. Now, suppose a man walks a certain distance due north, and then another distance due south. That distance is going to have a magnitude, its size. If I'm to mention, for example, let us put it in writing. Suppose a man, the girls are complaining, why am I not using a girl? Okay, you can put a girl in your notes. So suppose a man walks 4 kilometers due north and 1 kilometer due south. Not forgetting this, dear viewers, there are certain units which we are going to be using. Units of different quantities. A unit like kilometer, meter, we are going to use the joules. Things to do with Newton, that is unit of force. We are going to use that. A watt, a second, time is going to be so much used here. Okay, mass. So, you should be knowing the units of those quantities. The quantities I'm talking about which are going to be commonly used here in mechanics are these. Talk about force. Let us start with mass, which is measured in kilograms. So you should be knowing the unit. Small g, small k. So small k, small g. So force, the standard international unit is a Newton. We shall talk about time. And the standard international unit is a small s, which is a second. Then we shall talk about work, which is measured in joule, and it is the same as energy. Energy is also going to be measured in joules. Then we shall talk about power. Mostly these are the quantities we are going to emphasize as far as mechanics is concerned. So power, which is going to be measured in what? In watts. So I've quoted for you these 6 quantities with their SI units. When I talk of SI unit, is a standard international unit, a unit which is accepted internationally, yes, from headquarters of Britain, where the standard international, committee sits and then decide about what is supposed to be used as standard. Now, these are 6. Remember, I quoted for you 6 conversions which are used in mechanics. I've again quoted for you 6 quantities which are commonly used. So, when I talk of a kilometer, I've not talked about distance. Let me quote for you 7. Okay, so distance, and the unit is a meter, small m. So here I've used a kilometer. This man walked a very, very larger distance. So we are just supposing, we are imagining, okay? So suppose a man walks 4 kilometers due north. I want to emphasize the issue of magnitude, which is size, and then direction. So a man walks 4 kilometers due north and 1 kilometer due south. So let us go and see the total distance moved by this man, which is now going to serve as the size, total distance. Okay, so total distance moved by the man, total distance moved by the man is, okay, what will be the total distance, dear class? Okay, we shall get the 4 kilometers, we add the 1 kilometer without even looking at the direction, which means the quantity we are getting is a scalar at this instant. This is a scalar. So total distance moved by the man is 4 kilometers, then plus the 1 kilometer, okay, so which will finally give us 5 kilometers. This is a small k, a small m. You should note the case of these quantities and units. Okay, so this result is a scalar. This result is a scalar. People are asking, why is teacher writing on the board? For your own notes. What I'm giving notes from where we started. You are supposed, those who are watching me as a recorded teacher, you need to pause that device. If it is a flash drive, if it is a DVD, pause it and try to copy what you are saying. I always give you a clear posture for you to copy. I know you are my new students, you are not used to this, but you are going to get used to it slowly by slowly. So the total distance moved by this man is a 5 kilometer. And the result we have seen is a scalar. So to know how far the man is displaced from the original position or from the starting position, then direction comes into play. The people now will appreciate the study of the vector, because now we cannot tell how far this man has been displaced from the original position, if at all we don't bring in the issue of direction into consideration. So the distance is now going to change from distance to displacement. So for those who are making notes, this is very, very good to note. Those who are watching me live, automatically you have to take your notes. That's why I'm using very simple English and I'm slow in my speech. So we are saying that to know how far the man is displaced from original, which is the starting, from the starting position, then we need to talk about the direction. So then direction comes into play. direction comes into play. And then this direction is going to give us the displacement. So what are we going to see? We are going to see that displacement of the man is going to be, okay, now we are going to treat a 4 kilometer due north as positive, and then a 1 kilometer due south, because it changed the direction. A vector, we are interested in the direction. Once the direction is reversed from the beginning direction, then that alternate direction is given a negative sign. So in this kind of arrangement, we are going to say that the displacement of the man is 4 kilometers, okay? This is due north, then plus 1 kilometer due south. However, this is the same as saying 4 kilometers minus 1 kilometer. If you want the whole displacement to be in one direction, because this man took a lot, moved a lot of distance, do you know? Okay? So, this is going to be north. If I'm to demonstrate this, take a look at this. This was the starting point of the man. This is the man. Okay? And what we are seeing, the whole of this is north. This is north. You will agree that this is north. And then this is the southern direction rather. So this is south. So this man starts from here, or started from here, covering all this distance, assuming the 4 kilometers are these ones. So the 4 kilometers are moved northwards. Then from here, after making 4 kilometers, the man decides to go 1 kilometer downwards in the southern direction. But he has not reached the south, he is still in the north portion. Okay? But the total displacement is no longer at this position. If he started at O, he reached a position A, then he has come behind up to a position B, but still in the northern portion. I don't know whether my new students are getting me. Still in the north portion, in the area of north. So that's why we are having north. However, the total distance which was originally moved has reduced. I mean the total displacement. How far this man was displaced is now reducing to a smaller value, and we are going to observe it here as 4 minus 1, which gives us a 3 kilometers due north. Is still in the northern direction. Yes, that is very true. Due north. That's what we are seeing. Very interesting. So, what we have stated here is a vector. 3 kilometers due north is a vector. And the answer is totally different from the total distance moved by the man. If we are now focusing at only distance, which is a scalar, this man moved the 4 kilometers and then moved behind 1 kilometer, which we cannot ignore. So that is a full 1 plus 5, which gives us 5 kilometers. That is the total distance. But how far this man is displaced? The man is just 3 kilometers from the starting point in the northern direction. Hope people are trying to get what teacher slide is talking about tonight. So that is 3 kilometers due north, which is the displacement. So therefore, this is displacement. That is displacement. So we are going to see that in our mechanics, there are quantities which are vectors and those which are scalars. A scalar quantity with only magnitude, we consider its size. And then a vector quantity which brings in what we call size and direction, which size is also called magnitude. But now the size of a vector may not be the same as the size of a scalar, because direction in a vector affects the magnitude. direction affects the magnitude, as we have seen. That direction has affected the magnitude. Just one step back has affected the magnitude of how far this man is displaced.